Welcome to Web Development Through Practice. In the previous parts, we covered several PHP OOPS concepts. To better understand all those concepts, you should watch Part 1 and Part 2. Now, in this video, we will discuss class constants, method overloading, and key design patterns including the singleton pattern, factory method, observer pattern, MVC pattern, and the repository pattern. So, let's start with class constants. A class constant is a value that does not change after it has been declared within a class using the const keyword. For example, in an e-commerce website, we use some default values for calculations, such as the default currency, USD, free shipping threshold is $50, and default shipping cost is $5. So, instead of hard-coding these values throughout our code, we can create a separate file called e-commerce constants and define these values as follows. Now, we use these constants in the payment gateway class by including the e-commerce constants class file. Then define the calculate total method, where we check if the cart total is greater than or equal to the constant value of free shipping threshold. If yes, shipping is free. Otherwise, the shipping cost is set to the default constant value. Here, we access the constant by using the class name e-commerce constants along with the scope resolution operator and the constant name. Next, constants can have access modifiers, public, protected, and private. If we do not specify an access modifier, the constant is public by default. Now, if we change the constant to protected, then within the payment gateway class to use these constants, we will need to extend the e-commerce constants class. And in this case, we can access the constants using the parent keyword or the self keyword. Next, in the e-commerce constants class, if we change the protected constant to private, then the payment gateway class will show an error because private constants can only be accessed within the same class. Next, let's discuss method overloading. This means you can create multiple methods with the same name but different parameters. However, PHP does not support method overloading directly. To achieve this, we use magic methods such as call, get, and set. For example, we define the call method with two parameters, $function_name and $arguments. Inside the call method, we check if $function_name is equal to multiply. If it is, we define the logic to multiply a varying number of arguments. The call method is automatically triggered when you try to call a method that doesn't actually exist in your class. As you can see, we haven't explicitly defined a multiply method in the calculator class, yet we can still access it, and we can implement the multiply method to accept different numbers of parameters. Next, if you want to call the multiply method without creating an object of the calculator class, you need to make the method static and use the call static magic method instead of call. Then, you can remove the object creation and call the method directly using the class name, like. Next example, in Laravel's Eloquent model, you often see something like. But there's no method called where email defined in the user model. That's because Laravel uses dynamic scopes and the call static magic method behind the scenes to handle these types of dynamic method calls. Next, let's discuss the singleton class. This means you can create only a single object of class throughout the application. For example, we have db.php file used for managing database connection, and we use it in the user class, admin class, and seller class. Each time we create a new object of the DB class and connect to the database through the DB class constructor and the getConnection method. This means it opens a new connection to the database each time, which wastes memory and creates too many connections. So, to solve this, we convert the DB class into a singleton by make the constructor and the connection variable private so that no one can directly access it. Next, define getInstance static method, which creates the object of the DB class, and to store this DB class object, we define private static $instance variable and assign the DB object to the $instance variable using the self keyword. Here, we check whether $instance already has DB class object. If it does, we return that existing BD class object. Otherwise, we create a new DB object and return it. Now, to access the DB connection, simply call the static getInstance method followed by the getConnection method. The getInstance method first checks if the DB object has already been created. If so, it returns the existing object through the getConnection method, allowing us to share a single connection throughout the application. No repeated objects, no memory waste. And if any developer tries to create object of DB class, then it shows fatal error. Now, key points to remember are 1. Make the constructor private. 2. Create a static property to hold the single instance of the class. And 3. Define static getInstance method to access the instance. Similarly, you can use the singleton class pattern for configuration loaders, loggers, and caching services. Next, let's discuss the factory method. The word factory means a place where things are created or manufactured. Similarly, in programming, a factory is a class where we create and manage different class objects. For example, we create a factory class with createStatic method, and inside this method, we use a switch case to return objects like user, admin, or seller. Now, notice that we are using a single create method to different class objects, and that's why it's called a factory method. Now, when we need an admin class object, we don't directly use new admin. Instead, we access it via the factory class, and we don't need to know how the admin class works. We just use the object, and this is encapsulation where it hides object creation logic. Next, you can easily add new classes without touching the old code, and you can reuse the same factory class in multiple places across your application. Next example is Payment Factory. We have different payment gateways like PayPal, Stripe, and Razorpay. Each of these has its own logic, but you want to interact with them through one common interface. So, we create a payment gateway interface with abstract method process payment, and PayPal, Stripe, and Razorpay implements this interface. Next, we create a payment factory class with create method and pass the $payment type and return class object that implements the payment gateway interface. Here, instead of using switch, we can use a match expression for cleaner code. Then, when we want to process a payment through PayPal, we call payment factory with createStatic method and process payment method. Now, key points to remember are 1. You can implement the factory method with or without interfaces, but using an interface is a best practice. 2. The create method in the factory class is usually static, so you can call it without creating an object. 3. Don't use factory method for very small or simple projects. Next, let's discuss the repository pattern. As we know, the factory method is specifically used for object creation, while the repository pattern is used to centralize and manage all data access logic in one place, and other parts of the application access data without needing to know how that data is fetched or stored. For example, we have user class with register method that inserts new user data into the database using an insert query. Similarly, we have an admin class with an add new user method, which also performs an insert query to add users from the admin panel. Here's the problem. We are repeating the same insert logic in multiple places, once in the user class and again in the admin class. Instead of duplicating this code, we can create a crude repository class. In this repository, we define an insert data method that handles the insert logic. fetch data method to retrieve records from the database, and a delete data method to remove records. Now, both the user class and admin class can call the CRUD repository to insert user data. So, repository pattern writes the logic only once and avoid code duplication. It becomes easier to maintain and test. Next, let's discuss the observer pattern. Observer means the ability to notice changes. In programming, one class, called the observer, watches for changes or actions performed by another class, called the subject. When the subject changes or performs an action, it automatically notifies all attached observers, and each observer runs its own logic. For example, suppose you want to send notifications in different situations, such as after user registration, after placing an order, or after launching a new offer. Instead of writing the same notification logic in each class, which causes code duplication and tight coupling, we create notification observer class. In this class, define handle method with arguments, event type and notification data, and implement the logic to send notifications using a switch statement based on the event type. Now, to attach this notification observer to the user class, first include the notification observer class file in user class. Then, define an attach method with observer as an argument. Now, to store the observers, define private $observers array where the observers can be kept. Next, define notify method. Inside this method, use for-each loop to iterate through the attached observers and call their handle method, passing the event type, such as user_register, and the notification data. This handle method will then execute the notification logic. Next, within the register method, call the notify method. Now, to implement this flow, create object of the notification observer class and store it in $notifier. Then create object of the user class and store it in $user. Afterward, attach the notification observer using the attach method. When the register method is called, it triggers notify, which then calls the handle method in the observer, where the actual notification logic is executed. Similarly, you can apply the same observer logic in the order class and offer class. However, there's a problem. Each class, user, order, offer, includes similar attach and notify methods. To avoid repeating this code, we create new observable abstract class and move the attach and notify logic into it. After that, observable class is extended by the user class, order class, and offer class. This approach avoids code duplication across multiple classes. Here, key points to remember are: 1. Create an observer to write your logic in one place. 2. In any class where you want to use it, define attach to attach the observer. 3. Define notify to call the observer's handle method. You can also attach multiple observers if needed. For example, you might want to send a notification and log the event during registration. So, this way, the notification logic stays in one place and is reused across multiple classes, making your code cleaner, more maintainable, and scalable. Don't forget to like, share, and subscribe for more